Anybody think they know? Okay, so you of the 0.8. Okay, so we got the 0.8. Okay, and we move that decimal 2 places, which would give us 80%. We would subtract 100. Okay, same thing that we did with our exponential growth, right? But this time we get negative 20%. It's negative because it's decreasing, right? So the percentage of oil that is removed from the water each day would be 20%. I think it's probably easier than growth because you've already learned growth. And this is pretty much the same as growth, except for we're going to have numbers below 1 for our B. Okay, questions? All right, so 20% of the oil is removed each day. What percent of the oil remains each day? 80% is left, right? So 80 is the percent that's left, 20 is the percent that is removed. All right, so we need to know how much oil remains after 4 days. So, Emma Grace, what would we do for that? X is our time, right? X is days, so we just plug in 4 for our X. Okay, 22,937.6. All right, somebody check and make sure she's right. We can trust her. Okay, Emma Grace says so. Some of you are like, I don't care. I didn't have to do it. So good enough. 56,000 times 0.8 to the fourth. Okay. All right. 0.8. She's right. Okay, good. And this would be liters of oil. Okay. Okay. All right, questions so far? Yeah. They did. She did. She sit back there the whole time. Thank you for making me look good, Jesus. Appreciate it. All right. Okay. All right. So, 9. If a spill is considered cleaned up after 90% of the oil has been removed, how long does it take to clean up this spill? Because cleaning up an oil spill is going to, to get 100% of the oil gone is almost impossible, right? Because the water, especially ocean's even worse because you've got waves and tides and all of that stuff. But even in a still pond, unless you just pump every drop of water out and replace it with new water, which is impossible in an actual pond. I guess if it was a swimming pool, you could do that, right? But unless you completely remove all the water and put fresh water in, there is no way you can get it 100% cleaned up. But if it's considered cleaned up after 90%, so that gets enough that what little bit of amount of oil is left, you're not causing major environmental harm anymore. It's considered cleaned up. You're not going to have the boats and all of that stuff in there trying to clean up anymore. We want to know how long this takes. So first of all, we have to figure out how much oil that is left. 90% cleaned up. So Aiden, if it is cleaned up when 90% of the initial oil spill is gone, I need to know how much oil would be left. Okay, 10%. So I need to find 10% of what number? Okay, no, because this is not how much oil was spilled, right? 56,000. So we're going to find 10% of 56,000. So we're going to do 56,000 times 10%, and Evan knows that that is 5,600. And he knows it really quickly without a calculator, right? Because 10%, we just move that decimal one place. Good. So if we get down to 5,600 liters of oil, which still sounds like a whole lot, but it's better than 56,000, I guess. So if we get all of that up, then the spill is considered cleaned up. You can send all your workers and boats and stuff home. Okay? So how are we going to figure this out? Plug it into? Where do we put it? Y equals. So we plug our equation into y equals. So I want everybody doing this. Everybody on your calculator plugging it into y equals. Because some of you the other day were still asking me where to plug it into the day of the quiz. Okay? That tells me you have not been following along or doing it on your own. Okay? So y equals is up here in the top left-hand corner. You're going to type in your equation. Yeah. Okay? Now we go to second graph, which is table. Okay? I want everybody to figure out when this is going to happen. 5,600. I think I see it here. Okay? So 10 to 11 days. So the workers would need to be there 10 to 11 days cleaning that up. Maybe 11 just to be safe. Yeah. Okay? This is sort of a simplified version of this because you guys are ninth graders, not technicians working on rigs that clean up oil spills. But this is a real life situation. So this is something people would actually need to figure things out, because whenever you have an oil spill, we all know how terrible that is. That you guys would probably be much more familiar with the BP oil spill that happened several years ago. And it was in the Gulf of Mexico, and it was really bad, and they would put it on the news a lot. So I hope you might remember that. I'm sure that you don't. I don't remember the Exxon Valdez. I was 4 at the time. So I guess 3. I was 3 at the time. So I know you guys don't remember that actually happening. Yes.
Whenever we used to live in Charleston,
Uh-huh.
whenever they still go down there, there's this bridge they got that's like a mile long or so. They got boats like this that go under there all the time.
Mm-hmm.
And this bridge, like, it'll fold. It's crazy.
We went on vacation a few years ago. They have really cool bridges down there. And it is crazy. If you've not been to like a port city, like Charleston, like all the boats coming in is pretty crazy. Port, P-O-R-T. P-O-R-T. So if you haven't been to one, they are really cool to see. You see all these like big boats. You see some like that are like oil boats, but you see a lot of the boats coming in with all those shipping containers on them. They're just stacked up really high. Yeah. Okay. All right. Okay. Let's talk about something. Focus. All right. So this is a little bit of review. Y equals A times B to the X. A is your initial value, like Julie just told us. All right. So far, we have said B was the growth factor, but B can really be the decay factor also. We just didn't do decay yet. So this is either your growth or decay factor.
I think growth sounds better than
Right, but sometimes you have decay. So, like, growth does not apply whenever you're talking about decay. So this is whenever we have to do 100% plus or minus the rate if it's a decay, and then change it to a decimal. Okay? And then X is still always some sort of time. So for that B factor, that growth or decay factor, if you have growth, you're going to take 100% and you're going to add the rate. So it's like sales tax, 100% plus 7% gives you 107, move the decimal 2 places, right? So when you do that, you always get a B value that's greater than 1. So if B is greater than 1, the equation is an exponential growth equation. Mm-hmm. Yes. In this class. Because it's so applicable. There's so many places it can be used. In this class, yes.
What
Yeah.
about pre-calc?
I don't know if I have a favorite on pre-calc. Math 2 trig is my favorite.
And what is that?
Trigonometry.
What
It's
about
real, calculus. I like probably related rates the best, or maybe volumes of
I'll
revolution.
figure that out when I take the class.
All right. So if B is between 0 and 1, so here we're talking about decimals like 0.1 or 0.997, or you could even have a fraction like 1/2 or 3/4. Okay? Any number that's between 0 and 1, that equation is going to be exponential decay.
Is that 3/4?
Yes. Okay? All right, so let's look at the next problem. Okay, so I've got several here. Okay? Some of them are growth, some of them are decay. All right? Some are growth, some are decay. And so the first thing I want you to do right now is I want you to go through and decide which ones are growth and which ones are decay. Okay? So just right now, you don't have to do initial value. You don't have to do anything else. Just do growth or decay. Also, I don't know who put this on my board back here, but if I see something like this drawn on my board again, then the whole class is going to be punished until I figure out who did it, and that person will go to the office, because that is not cute or funny. So, I don't want to see that anymore. I don't mind if you write things like Bon Jovi quotes on the back of the board. But if I see a swastika anywhere in this room, then somebody is going to be in big trouble. Not December. Yeah. And we're going to say probably Julie didn't do it. But yeah, I cut it off. So, all right, so all right, Tristan, give me one that is growth. Okay, 10 is growth. All right, let's see, Cole, another one that's growth. 15 is also growth, yes. All right, Adam, another growth. There's only one left. It is 13, good. Okay, all right, those are the only ones that are growth, I think, yes. The rest of them are decay. All right, so what I want you to do now is I want you to go through and tell me initial value and your growth or decay rate. So we've already done one. So for example, if we did number 14 here, initial value, what is it, Aiden? Okay, and then for the, in this case, it's a decay rate. Okay, you do the same thing that you did with the growth rate. So you're going to move that decimal 2 places. That gives you 12%. You're going to subtract 100%, which gives you 80. You can do it in your head or on your calculator. I'm just writing it out so everybody sees it. You get negative 88%. The negative tells you it's decay. You don't include the negative. And then you want, no, you don't have to change that back. So then that is your answer, 88%. You don't have to include the negative because the word decay tells me that it is negative. It's going to be decreasing. Okay? All right. Questions on how to do that? All right. Everybody do the rest of these. Okay? All right. Number 1, 5,000 is initial value, 7% growth. All right. That's 10. Sorry, 10. 11, 30 is your initial value, 20% decay. 12, 1 is your initial value because you don't have an initial value, and 66.6 repeating is your decay. 66.6 repeating. 13, initial value is 500. Your growth rate is 100%. 14, we've already done. 15, initial value is 3,500. Growth rate is 4%. 16, initial value is 2. Decay rate is 60%. And 17, initial value is 600. Your decay rate would be 0.7%. Okay? All right, homework. You only have to do that top part. It's number 1 through 8. 1 through 8. It shouldn't take you 5 minutes. Please do it.